Now in this video, we're going to take up one more problem. The problem number 4. It treats as a solid shaft is subjected to a maximum torque of 25 kilonewton meter. Find a suitable diameter of a solid shaft. If the allowable shear stress and the twist are limited to 80 Newton per mm square and 1 degree respectively for a length of 20 times the diameter of the shaft. This has been asked once in the examination on December 6, January 7th, 2007. Now, first we will going to take up the data, what all it is given. So he says torque, maximum torque is given, which is T max will be equal to 25 kilonewton meter. So convert that into mm. So 25 into kilo is converted into Newton, which is into 10 to the power of 3. And meters is converted into mm, again into 10 to the power of 3. So therefore, you are going to get it as 25 into 10 to the power of 6 Newton mm. So you need to find out the suitable diameter of the shaft, capital D. And if the allowable shear stress is 80 Newton per mm square and theta is given as 1 degree, which will be equal to pi by 180 radians, 1 into 1. So similarly, the length of the shaft has been given as 20 times the diameter. Once you know the diameter, then only you can calculate the length of the shaft. So first we're going to consider the solid shaft diameter based on strength criterion. What is the strength criterion says? That is T by tau will be equal to Jp by R. So therefore, torque will be equal to tau into Jp by R. So that will be equal to Zp into tau, which is section modulus. So that is torque is the torque is given by the section modulus of the solid shaft is pi dq by 16 into tau. So we know the values of torque. So you substitute that, it is 25 into 10 to the power of 6, which will be equal to pi into dq, which I need to find out, into tau is 80 by 16. So pi into d cube into 80 by 16. So therefore, the diameter of the solid shaft is calculated from the strength criterion as 116.75 mm. Now we will going to find out the solid shaft diameter based on the rigidity criterion. So that is T into theta by L will be equal to T by Jp. So we know the value of GH is given as 80 into 10 to the power of 3 Newton per mm square. We are assuming the value is not given, it is 80 GPa. So then we know, substitute the values now. What is now we need to find out is T, which is 25 into 10 to the power of 6 Newton mm. Substitute that, divided by Jp is pi d to the power of 4 by 32 will be equal to G is 80 into 10 to the power of 3 into, convert the theta, that is 1 degree, into 1 into pi by 180, 1 into pi by 180 divided by the length of the shaft, which is given as 20 into d. So substitute that. So on simplification, what happens in the left hand side, 25 into 10 to the power of 6 into 32 by pi d to the power of 4. So that d gets cancelled from this d, and this d will going to get cancelled. So you're going to get it as pi into d cube will be equal to 80 into 10 to the power of 3 into pi by 180 into 20. So on simplification, the diameter of the solid shaft will be equal to 153.934 mm from the rigidity criterion. So now we have the two diameters. One is on the strength criterion and the other one is on the rigidity criterion. When we are considering that, we have to consider, when you are comparing these two values, you have to consider the maximum diameter. So the permissible diameter is the bigger diameter among the two values. Therefore, when you are considering that, you will going to get D will be equal to, the diameter of the solid shaft will be equal to 153.934 mm, which is the higher value. You can adopt that. So which is approximate to 154 mm. So this is how you will be able to calculate the diameter of the solid shaft. Thank you.